Hello students, welcome to the class. So in the previous class, we have discussed some set of questions on equilibrium. Moving to the next set of questions. 48th question, the conjugate acid of NH2 minus is NH4OH, NH4 plus, NH2 minus and NH3. See, we have studied that if you want to write the conjugate acid or a conjugate base, yes, we have already know that for an acid, its conjugate base is written how? If you want to write conjugate base, we write it as, we'll remove one H plus and it becomes conjugate base. If a base is given and if you want to write the conjugate acid, then how do we write conjugate acid? We will add one H plus ion, correct? So they have asked conjugate acid. That means what they have given is base. The base given is NH2 minus. And they have asked us conjugate acid. So this is the base. I want to write conjugate acid for it. So what I will do here to write the conjugate acid, I have to add one H plus ion. Then it will become conjugate acid, correct? Conjugate acid. So adding one H plus ion becomes what? It becomes NH3, conjugate acid. So I can mention it like this also. You have a substance, you add one H plus ion, it will become conjugate acid. It will become conjugate acid. You have a substance, you remove one H plus ion, it will become conjugate base. It will become conjugate base. Yes, you can remember it either in this form or you can remember it either in this form. Is that right? So which is the correct option? It is NH3, that is ammonia. NH3 is the correct option. Next question, which compound is electron deficient? Electron deficient means what? Which is not having octet configuration. So BeCl2, BCl3, CCl4 and PCl5. So let us look at the Lewis structure for all these molecules, then we can come to the conclusion. So first one is BeCl2. BeCl2, beryllium is the central atom, and we know that beryllium atomic number is 4. It is 1s2, 2s2. When beryllium tries to combine with the chlorine to form a covalent bond, it involves its two valence electrons, shares it with chlorine. So chlorine will complete, both the chlorine atoms will complete its octet, but beryllium is not having its 8 electrons, but still beryllium has only 2s configuration and it is completely filled. Therefore, I cannot say beryllium is electron deficient. If you look at carbon tetrachloride, CCl4, carbon has got 4 valence electrons in its outermost shell, and those valence electrons are involved in sharing with the chlorine atom to form CCl covalent bond. So all the chlorine atoms have completed their octet. Whereas carbon, look at the carbon, carbon completed its octet state. Yes, carbon also has 8 electrons in its outermost shell. If you look at PCl5, phosphorus belongs to group 15. It is having 5 valence electrons in its outermost shell. These 5 valence electrons, they are utilized with sharing with chlorine atoms, 1 electron each with 5 chlorine atoms, so that all the chlorine atoms will complete their octet. I am not showing the remaining 6 electrons or 3 pairs of electrons. All chlorine atoms will complete their octet. What about phosphorus? 2, 4, 6, 8, 10. So phosphorus is what? It is expanded octet. It is what? Has expanded octet. So it expanded octet cannot be what? Cannot be electron deficient. It is electron rich, more than 8 electrons, correct? Then last option left is BCl3. So if you look at BCl3, boron atomic number 5. So there are 3 valence electrons. 3 are involved in chlorine, wherein all the 3 chlorine atoms will complete their octet. But what about boron? Boron is having only 6 electrons. So in BCl3, The central atom boron has got less than 6 electrons. It is what? Incomplete octet. And we know that incomplete octet, the compounds which have incomplete octet on their central atom, they are electron deficient molecules. They are what? Electron deficient molecules. So which is our correct option? The correct option is BCl3. Yes. Next question. The strongest conjugate base is SO4 minus 2, HCl minus, NO3 minus, CH3COO minus. When we write acid and its conjugate base, whenever we write acid and its conjugate base, which is the weakest acid, its conjugate base will be strong. The weakest acid, see, if you have strong acid, yes, its conjugate base will be weak. If you have strong base, its conjugate acid will be weak. If you have weak acid, its conjugate base will be strong. And if you have weak base, its conjugate acid will be strong. Yes, so please do remember this. Strong acid, conjugate base will be weak. Strong base, conjugate acid will be weak. Weak acid, conjugate base will be strong. Weak base, conjugate acid will be strong. So, as out of the given options, SO4 minus 2 is formed how? By removing H plus ions. 2 H plus ions from H2SO4. And H2SO4 is what? H2SO4 is a strong acid. Cl minus ion is formed how? By removing one CH plus ion. And HCl is what? It is also strong acid. And NO3 minus ion is formed how? By removing one H plus ion. So HNO3 is also strong acid. I hope you know what are strong acids. They dissociate completely, yes, in the solutions. If you look at CH3COO minus ion, it is formed by removing one H plus. It is nothing but CH3COOH, acetic acid, and acetic acid is a weak acid. It is a weak acid, therefore it dissociates partially to give me CH3CO minus plus H plus. So this is the strong, this is a weak acid, therefore its conjugate base will be what? It will be very strong. Compared to all of them, the conjugate base of CH3COH is strong. So since acetic acid is a weak acid, so its conjugate base, that is acetate ion, is the strongest base. If you look at H2SO4, HCl, HNO3, they are strong acids. Their conjugate bases will be what? Their conjugate bases will be weak bases. Their conjugate bases will be weak. So which is the correct option here? The correct option is CH3COO minus. Next question. Which of the following is not Lewis acid? SiF4, C2H4, BF3, FeCl3. Okay, let us look into the explanation. Which of the following is not Lewis acid? Lewis acid is what? Lewis acid is electron pair acceptor. Electron pair acceptor is Lewis acid. Any compound which is electron deficient will act as Lewis acid. Because it has to accept the electrons means what? It is having less electrons. So given options are SiF4, then we have C2H4, then we have BF3, and then we have FeCl3. Yes, if you look in BF3 and FeCl3 molecules, the central atom have incomplete octet, yes or no? Either you look in BF3 or you look in FeCl3. The central atom has less than 8 electrons. So these are the both examples where there is incomplete octet. Incomplete octet. Okay, they have less than 8 electrons. Yes. And in SiF4, if you see, SiF4, if you observe, the central atom has empty d orbitals. Central atom is what? Silicon. It has empty d orbitals. Yes. Hence, according to Lewis concepts, these are all what? These are all electron pair acceptors. Therefore, they all act as Lewis acids. But you look at C2H4. What is C2H4? Do you know what is C2H4? C2H4 is ethene, or sometimes it is called as ethylene. Okay. C2H4, it will utilize its bonds like this. So all the electrons are involved in bond, covalent bonding. So this carbon has completed its octet. This carbon has also completed its octet. Therefore, we can say there are no less electrons here. This is not electron deficient molecule. It is electron precise molecule. It is electron precise molecule. So you may say sometimes silicon also belongs to carbon family, but unlike carbon, silicon is having what? Empty d orbitals. So it can take the electrons. It can take the electrons. Carbon does not have empty d orbitals. Therefore, which is not Lewis acid? It is C2H4, which is not Lewis acid. Yes. So C2H4 is not Lewis acid. Repeated use of which of the following fertilizers would increase the acidity of soil? Ammonium sulfate, sulfur phosphate of lime, urea, potassium nitrate. So for these are all fertilizers, but repeated use of which fertilizer increases the acidity of soil? It is option A, ammonium sulfate. Ammonium sulfate is what? NH4 twice SO4. This is ammonium sulfate. Yes, it is what? It is a salt. It is a salt of what, you know? It is a salt of strong acid and weak base. I'll just show you how it is formed. H2SO4, strong acid, plus NH4OH, weak base. They will combine to form NH4 twice SO4, ammonium sulfate. Therefore, the repeated use of ammonium sulfate would increase what? Yes, repeated use of this compound would increase the concentration of sulfuric acid H2SO4, while ammonia from NH4OH is used up by the plants. Yes, H2SO4 concentration will increase, but this ammonia which is released, it will be used up by plants. NH3 will be used by plants. It will be used by plants. Hence, the acidity of soil will increase. The acidity of soil will increase. Yes. So, which is the correct option? It is ammonium sulfate. Otherwise, if you see, they are all contain basic nature. Yes. Okay. Next one. Find out the solubility of nickel hydroxide in 0.1 molar NaOH, given that ionic product of nickel hydroxide is 2 into 10 raised to minus 15. Okay. A numerical. We'll solve it out. So what they have said, nickel hydroxide solubility we are supposed to find. So let us see how nickel hydroxide dissociates. NiOH twice, it dissociates partially to give Ni plus ions plus OH minus ions. Okay, so this is a solid. This also are solid ions, and this is, let me represent it as S. This is what? Solubility. So S stands for what? S stands for solubility. Okay, of nickel hydroxide. Okay. Now, in 0.1 molar NaOH they have said. So NaOH is what? It is a strong base. So 0.1 molar means, again we'll consider it like this. Gives me Na plus plus OH minus. And how much they have said? They have said 0.1 molar. It will dissociate to give me 0.1 molar of NaOH, Na plus ions, and 0.1 molar of OH minus ions. Correct? Okay. So here OH minus ions, yes, I will write as solubility. Since the coefficient is 2 here, I will put 2 coefficient here. So let me find out the OH minus ions. It is equal to what? In nickel hydroxide, it is 2s, plus in NaOH, it is 0.1, which is almost equal to what? Which is almost equal to 0.1 only. Because 2s is what? It is very much less than 0.1. Yes or no? 2s solubility, it is very much less than 0.1. Now, what is the ionic? Okay. What is the ionic product of nickel hydroxide? NiOH twice. I'll write it as Ni plus 2 concentration into OH minus concentration raised to what? Raised to 2, because there are 2 OH minus. That is equal to, so 2 into 2 into 10 raised to minus 15. They have given ionic product. 2 into 10 raised to ionic product of nickel hydroxide is given. 2 into 10 raised to minus 15 is equal to, nickel is yes, into, and OH minus we have seen it is 0.1 the whole square. Yes, solve it out. How much you get? Yes is equal to 2 into 10 raised to minus 15 divided by 0.1 into 0.1. Correct? And this comes out to what? 10 raised to minus 2. 2 into 10 raised to minus 13. 10 raised to minus 2 goes to the numerator plus 2. So it becomes 2 into 10 raised to minus 13 molarity. So the correct option is option A, 2 into 10 raised to minus 13 molarity. Is that clear? Okay, next question. The pH of 0.01 molar NaOH solution will be. Yes, pH question. This is a question on hydrogen ion concentration. So we know that NaOH is a strong base. It dissociates completely to give me Na plus plus OH minus. It is balanced everywhere. So they have said how much? 0.01 molar. If this is there, then I will have 0.01 molar of OH minus, 0.01 molar of Na plus, correct? I am not worried about Na plus. I want OH minus. Therefore, I can say OH minus ion concentration is equal to how much? It is equal to 0.01 molar. Then what will be pOH? I know that pOH is what? Negative log of 0. molar concentration. That is equal to minus OH minus ion concentration. 0.01 is what? 10 raised to minus 2. Log of 10 raised to minus 2 is 2. Yes, here minus goes off. Minus minus gets cancelled. So I'll get the answer 2. This is what this is. Yes, I'll make it properly here. This is what? This is pOH. pOH is equal to 2. Understanding, students? But they have asked me what? They have not asked me pOH. They have asked me pH. And I know that pH plus pOH is equal to 14. Therefore, pH is equal to what? 14 minus pOH. And my pOH value is 2. Therefore, what is the pH? pH is equal to 12. pH is equal to 12. Is that right? So, which is the correct option? It is option C. The pH is 12. Next question. Following solutions were prepared by mixing different volumes of NaOH and HCl of different concentrations. 60 ml M by 10 of HCl, 40 ml M by 10 of NaOH, 55 ml M by 10 of HCl, 45 ml M by 10 of NaOH, 75 ml M by 10 of M by 5 of HCl, and 25 ml M by 5 of NaOH, and 100 ml M by 10 of HCl plus 100 ml M by 10 of NaOH. pH of which of them will be equal to 1? Okay, let us see. They have said NaOH and HCl. Okay, so let us work out and see. See, pH should be equal to 1. So if pH has to be equal to 1, then what should be H plus ion concentration? H plus ion concentration should be equal to 10 raised to minus 1. Yes, we have seen H plus ion concentration is equal to 10 raised to minus 7, means what? pH will be equal to 7. Understanding? So pH has to be 1 means H plus ion concentration should be equal to 10 raised to minus 1. So for this is acid and base mixture. Therefore, I can say for acid base mixture, what we can write is N1V1 is equal to N2V2, correct? N1V1 is equal to N2V2. Yes, for NaOH as well as for HCl. For NaOH and HCl, normality is nothing but molarity. Yes, normality is nothing but what? Normality is nothing but molarity. Understood? Okay, so let us take it for one by one. Let us consider it one by one here. Let us say I will take first option. First option, what it says, M1, I have to find H plus ion concentration. Therefore, M1 is equal to M1 of H plus ion concentration is equal to what? They have said 60 ml into M is what? M is 1 by 10 minus 40 ml and then into 1 by 10. 1 by 10. Correct? H plus ion concentration. Is that right? Divided by what? Divided by 100. So it will come to what? It will come to 2 into 10 raised to minus 2 molarity. So pH will be what? Negative log of H plus ion concentration. When you solve it out, you will get around nearly 1.7. pH nearly 1.7. Take the option B. Option B for M2 H plus ion concentration 55 ml into 1 by 10 minus 45 ml into 1 by 10. Correct? Divided by what? The whole divided by 100. This you will get answer 1 by 100. Yes, when you solve it out, you'll get the answer 1 by 100, which is equal to 10 raised to minus 2. And pH comes out to what? pH will be 10 raised to minus 2 means pH is 2. Take the third option, M3 H plus ion concentration is what? M3 is equal to H plus ion concentration. What is given? 75 into 1 by 5. It is 5 minus 75 into 1 by 5 minus what is there? 25 into 1 by 5. Yes, 25 into 1 by 5. The whole divided by 100. Yes, solve it out. You will get the pH equal to 1. You'll get the pH here 1 because whole answer comes out to 10 raised to minus 1. Option 4, you just see H plus ion concentration. It is 100 into 1 by 10 minus 100 into 1 by 10. Solve this out, you will get the equal answer 0. 0 means what? pH is again 7. Yes, pH is again 7. Therefore here, since it is 100 ml, 100 ml, I will divide it by what? We will divide it by 200. So here 75 plus 25 is 100. 55 plus 45 is 100. 40 by 60 is 100. But here 100 plus 100 is what? Divided by 200. So answer will come 0 and pH will be 7. Getting my point? Therefore, what we say, where there is pH equal to 1, it is for option 3. So option C, the pH has got 1. So pH of which of the following will be equal to 1? It is option D. D, option C is the correct option. Is that right? Yes, D option is the correct option. That is C. Okay. Next question. The percentage of pyridine C5H5N that forms pyridinium ion C5H5NH plus in a 0.1 molar aqueous solution, pyridine solution, given Kb for C5H5N is 1.7 into 10 raised to minus 9 is. Okay. Let us solve it out and see. So pyridine and pyridinium ion it is forming. How it will form pyridinium ion? I'll just show you. Pyridine is C5H5N. Okay. And how much molarity is taken? 0.10 molarity is taken. Okay. It dissociates. It combines with H2O plus H2O, dissociates partially to give us C5H5NH plus OH minus. Yes. So degree of dissociation alpha. What is alpha? It is degree of dissociation. So degree of dissociation alpha for a base is what? It is root of Kb by C. If it is for acid, it will be root of Ka by C. That is equal to root of Kb. How much it is given? It is 1.7 into 10 raised to minus 9 divided by 0.10. Solve it out. You will get the answer 1.30 into 10 raised to minus 4. Okay. This is degree of dissociation. They have said percentage of pyridine that forms what? That forms pyridinium ion. pyridinium ion. So here how much we take? What answer we have got into 100? 1.30 into 10 raised to minus 4 into 100. How much you get? You will get 10 raised to 2 minus 4, my plus 2 gets cancelled, and 10 raised to minus 2 it becomes. So shift the decimal point to the left, we will get 0.0130%. Or you can write 1.30 into 10 raised to minus 2%. Anyhow, which answer is there? We will write in that form. So which is the correct option? It is option B, 0.013%. Correct? 0.013%. Next question. What is the pH of resulting solution when equal volumes of 0.1 molar NaOH and 0.01 molar HCl are mixed? Okay. They have said equal volumes. So we have to consider equal volumes. So let us take and solve it. So 1 mole of NaOH, if you see 1 mole of NaOH is completely neutralized by 1 mole of HCl. Correct? Hence, if they have given us 0.01 mole HCl, they have given how much? 0.01. Therefore, 0.01 mole of NaOH is completely neutralized by what? Completely neutralized by 0.01 mole of HCl. Correct? Yes or no? Because they have given in our question only 0.01 mole of HCl. And NaOH, how much they have given? 0.1 mole of NaOH. Because I have taken only mole here because volumes are same. So moles per volume is what? Molarity. Volumes are same, so I have ignored volume. And we know the reaction NaOH plus HCl gives what? NaCl plus H2O. So according to this balanced equation, you can see 1 mole of, if you see is here, 1 mole of HCl is used to neutralize. NaOH will neutralize 1 mole of HCl. Getting my point? So equal volumes of NaOH and HCl are mixed. Therefore, I can say from this explanation, NaOH left undisturbed will be how much? How much NaOH they have given? 0.1. Yes, minus how much is used? 0.01 is used. How much remains? 0.09 moles remain. 0.09 moles remain. Correct? As equal volumes of two solutions are taken, or you can say two solutions are mixed. Yes, what I can say? OH minus ions will be equal to what? 0.09 divided by 2. Because H plus into OH minus, it is 2 OH minus ions. So OH minus is 0.09 upon 2. That is equal to how much? 0.045 molarity. Therefore, that is OH minus ion concentration. What is POH? Minus log of 0.045. That answer, you can take it as 4.5 into 10 raised to minus 2. You will get the answer around 1.35. This is POH. They have asked what? pH. And pH is equal to what? 14 minus POH. That is 14 minus 1.35. The answer comes out to 12.65. pH answer comes out to what? 12.65. Is that understood? So 1 mole of NaOH is completely neutralized by 1 mole of HCl. Hence, if 0.1 mole of HCl is there, then 0.1 mole of NaOH will be neutralized by 0.1 mole, 0.1 mole of HCl. How much is left? Here 0.1 molar NaOH is there and this much is used up. So how much will be left? 0.09. Since they have said equal volumes, H plus ion concentration and OH minus ion concentrations will be equal. So H plus is equal to H minus. Therefore, it becomes what? It becomes like this. H plus into OH minus ion concentration is equal to 0.09. Since both are equal, OH minus ion concentrations is equal to 0.09 we write. So 2 into OH minus ion concentration is equal to 0.09. Therefore, OH minus ion concentration will be equal to what? 0.09 by 2. This is what I have written here. That will be 0.45. Find the pOH, negative log of OH minus ion. Answer comes out to 1.35. And pH will be what? 14 minus 1.35, and that is nothing but 12.65. So the correct option is 12.65. Answer D. Option D is the correct answer. Next, which of the salts will give highest pH in water? See, the salts of strong base and weak acid will produce basic solution with pH greater than 7. Highest pH means what? More than, it will be highest pH. pH range is 1 to 14. Highest pH means it should be in basic form, correct? So if you see KCl, yes, it is formed from KOH and HCl. Both are strong acids and strong base. NaCl, it is formed from strong acid and strong base, therefore not possible. Na2CO3, how it is formed? Na2CO3. So it is a salt of NaOH, which is what? Strong base, and H2CO3, which is a weak acid. So this is a salt of strong base and weak acid. Its pH produced. Strong base means base, it will be pH will be more basic. It will be more than 7. Rest all if you see, sulfuric acid is there, acidic, Cl minus is there. This both are neutral. So around 7 it will come. This is acidic, less than 7, and this is basic. Therefore pH will be weak acid it is. Therefore pH will be more than 7. So correct option is what? Option C is the correct option. So you have to see from which type of compounds, acids and bases, the salts are formed. Then we can speak about the pH. Next question. Accumulation of lactic acid H3HC3H5O3, a monobasic acid in the tissues leads to pain and a feeling of fatigue. In a 0.10 molar aqueous solution, lactic acid is 3.7% dissociated. That is, alpha is given. Degree of dissociation is 3.7%. The value of dissociation constant Ka for this acid will be. Okay. Some different question itself we have. Let us see. So they have given lactic acid. Yes. See, dissociation, degree of dissociation. Degree of dissociation alpha is equal to what? 3.7% they have said. So I have to convert it 3.7 divided by 100. That comes out to what? 0.037. So percentage has to be converted. They have said 3.7%. Okay, so I get degree of dissociation. Now which law we have come across? According to which law? Ostwald's dilution law. We have seen this. Ostwald's dilution law. Yes, according to Ostwald's dilution law, we know that dissociation constant for a weak acid is equal to alpha square into C. Or for weak base, it is equal to alpha square into C. Correct? Yes or no? Solve it out. So alpha is how much? 0.037 the whole square into what is the concentration given? Concentration given is 0.10. Yes, this 0.037 comes out to 1.369 into 0.10. Yes, when I solve it completely, I will get 1.369 into 10 raised to minus 4. Yes, solve this out. 1.369 is nearly 1.4 into 10 raised to minus 4. 10 raised to minus 4. So what is this? This is dissociation constant of a weak acid. Yes. So let us see which is our correct option. It is option 1.4 into 10 raised to minus 4. Yes. Okay. At 100 degrees Celsius, the kW of water is 55 times its value at 25 degrees Celsius. What will be the pH of the neutral solution? Log of 55 is given, that is 1.74. Okay. See, we know that for water, basically, at 25 degrees Celsius, yes, at 25 degrees Celsius, what is Kw? Ionic product of water is 1 into 10 raised to minus 14. Correct? 10 raised to minus 14. At 100 degrees Celsius, we are saying ionic product of water is 55 times its value. Therefore, can I write 55 into 10 raised to minus 14? Yes. And we know that ionic product of water is what? It is H plus ion concentration into OH minus ion concentration. Is that right? Therefore, for a neutral solution, H plus ion concentration and OH minus ion concentrations are same. I can write ionic product of water is equal to H plus ion concentration, 2 into H plus ion concentration, that becomes square. Yes. Therefore, what is H plus ion concentration? It is root of Kw, square root of Kw. And that is equal to how much? Root of 55 into 10 raised to minus 14. So what will be pH? Negative log of H plus ion concentration. And I have got here H plus ion concentration. Negative log of root of 55 into 10 raised to minus 14. 55 into 10 raised to minus 14. Okay, how do we solve it? Root is taken as 1 by 2. Then minus log 55 into 10 raised to minus 14. Minus 14. Okay, so half minus. Can I write this as? Okay, I'll take minus inside. Minus log of 55 plus 14 log 10. This can be written like this also. Yes, then solve it out. The answer comes out to half. They have given my log of 55 is 1.74 minus 1.74 plus this is 14. Log 10 is 1. Okay, therefore, simple calculations further, it becomes 12.626. Solve this out, you will get the answer 6.13. Is that clear? Yes. First find H plus ion concentration, then take the pH. This is pH. And solution, further calculations is left up to us. Yes. So 55 into 10 raised to minus 14 can be written as, when minus 14 is there, it comes here and becomes plus 14. Is that right? So answer is 6.13. What is the correct option? 6.13. That is the correct option. Yes. Next, equimolar solutions of the following substances were prepared separately. Which one of these will record the highest pH value? Barium chloride, aluminum chloride, lithium chloride, and beryllium chloride. Okay. What they have said, equimolar solutions. So look at barium chloride, BaCl2. It is made up of what? It is made up of, I can say it is made up of, barium comes from base, barium hydroxide, and HCl. Okay. Second one, AlCl3. It is made up of aluminium hydroxide and again HCl. Third option is lithium chloride. Lithium chloride. It is made up of lithium hydroxide, LiOH, and HCl again. Last one is BeCl2. It is made up of beryllium hydroxide and HCl. Okay. So out of all of this, if you see, barium hydroxide yes, is the strongest base. Is strongest base out of all the bases what you have seen. It is the strongest base. Barium hydroxide, aluminum hydroxide, lithium hydroxide, beryllium hydroxide. So it is the strongest base. So therefore it will have what? It will have maximum pH. Yes. So which one will record highest pH? It is barium chloride. Barium chloride will record for highest pH. Highest strongest base. So pH value will be more. Is that understood? Okay. What is the H plus ion concentration in moles per liter of a solution that is 0.2 molar in CH3CONa and 0.10 molar in CH3COH? Dissociation constant of CH3COH is 1.8 into 10 raised to minus 5. Okay. Let us solve it out. So how does CH3CO minus dissociate? CH3COH dissociates. CH3COOH is a weak acid, dissociates partially to give me CH3COO minus plus H plus. Yes. So initial concentration is C 0 0. After dissociation, if X you consider, it is C minus X. This is X and this is X. Correct? What is CH3CONa? It is a salt. It undergoes complete dissociation to give me CH3COO minus plus Na plus. Yes, and they have said it is how much? 0.2 molar. So this will give me 0.2. This will also give me 0.2 molar. Correct? Okay. Acetic acid CH3COOH concentration, if you see, it is how much? C minus X. And that is nearly equal to what? They have said acetic acid is 0.1. Yes, so it is nearly equal to 0.1 only. 0.1 molar only. Why? Because acetic acid is what? I'll write here. Because acetic acid is weak acid. So dissociation is what? Dissociation is very less. You can say minimum. It is minimum. Therefore, X can be neglected. It can be neglected. Hardly very less amount has dissociated. So X can be neglected. So I will keep C minus X is what? Hardly makes any difference. C is 0.1. Therefore, 0.1 into something is very less. It will remain 0.1. Similarly, CH3COO minus, what it is? It is 0.2 plus X, and we know that X is very less. So which comes nearly to what? 0.2 molar. Now let us calculate H plus ion concentration. First you write Ka, dissociation constant of an acid. Then we'll calculate H plus ion concentration. Ka is equal to what? Concentration of H plus ion into concentration of CH3COO minus ion divided by CH3COOH. Correct? Now if I want to find H plus ion concentration, I will take Ka into CH3COOH divided by CH3COO minus. Is that right? Okay. What is dissociation constant given? 1.8 into 10 raised to minus 5 into CH3COH concentration is how much? 0.1 divided by CH3CO minus is how much? 0.2. Solve it out. You will get the answer 9.1 into 10 raised to minus 6 molarity. This is what? H plus ion concentration. 9.1 or 9.0 you can say into 10 raised to minus 6. So it is correct option is what? It is option D. It is option D. Yes, is that clear? Next question. The ionization constant of ammonium hydroxide is 1.77 into 10 raised to minus 5 at 298 Kelvin. Hydrolysis constant of ammonium chloride is 6.50 into 10 raised to minus 2, 12, 5.65 into 10 raised to minus 13, 5.65 into 10 raised to minus 12, 5.65 into 10 raised to minus 10. Okay, let us solve it out. Fine. Okay, so here ammonium chloride, they have said it is what? It is a salt of strong acid and weak base. Yes, so I can write its hydrolysis constant. Hydrolysis constant will be what? KH is equal to KW upon KB. And given is what? They have given ionization constant of ammonium hydroxide. Ionization constant of ammonium hydroxide is written as Kb. And Kb value how much is given? 1.77 into 10 raised to minus 5. Correct? So solve it out. KH is equal to, how much is Kw? 1 into 10 raised to minus 14 ionic product of water divided by 1.77 into 10 raised to minus 5. Solve this out, you will get the answer 0.565 into 10 raised to minus 9. Or I can write KH is equal to 5.65 into 10 raised to minus 10. Shifting the decimal point this side, minus 1, it becomes minus 10. So which is the correct option? 5.65 into 10 raised to minus 10. Option D is the correct option. Yes. Next question. What is the OH minus ion concentration in the final solution prepared by mixing 20.0 ml of 0.050 molar HCl with 30.0 ml of 0.10 molar barium hydroxide? Okay. OH minus ion concentration. Okay, see, for finding that, we'll first see H plus. So can I say millimoles of H plus ion produced? Millimoles of H plus ions produced is equal to what? They have said 20, mixing 20 mole of 0.05 HCl. 20 into 0.05. How much it comes out to? It comes out to 1. Okay, then millimoles of OH minus ions produced. How much they have said? 30 ml of 0.1 is how much we'll get. It is barium hydroxide. So barium hydroxide, if you see, HCl has only one H plus ion, but barium hydroxide, if you see, barium hydroxide has OH minus ions. There are two OH minus ions. Therefore, this has to be multiplied by 2. Correct? And I will get the answer 6. Because each barium hydroxide will give me 2 OH minus ions. Therefore, the millimoles of OH minus ions remaining in solution will be how much? It will be 6 minus 1. That will be 5. Correct? Total volume will be how much? Tell me, of the solution. Total volume of the solution is 20 ml of HCl and 30 ml of NaOH gives me 50 ml. Yes, therefore, find the OH minus ion concentration. It will be 5 divided by 50. How much you get? 1 by 10 is nothing but 0.1 molar. Yes, very simple question. Understood? So, which is the correct option? 0.10 molar. That is the correct option. Next question. Equal volumes of 3 acids solutions of pH 3, 4 and 5 are mixed in a vessel. What will be the H plus ion concentration of the mixture? See, very beautiful question. Such questions are very interesting actually. Okay. So we know that what is pH? pH is equal to minus log of H plus ion concentration. Correct? Or I can write H plus ion concentration is equal to 10 raised to minus pH. I can write it like this also, which means H plus, which means H plus ion concentration of solution 1, if you say pH is 3 means what? It is 10 raised to minus 3. Understanding? Please remember this format. pH means it is H plus ion concentration, correct? It is H plus ion concentration. Yes, understanding. So what is H plus ion concentration means? H plus ion concentration means it is 10 raised to minus pH. 10 raised to minus pH. Getting my point? Therefore, H plus ion concentration, pH they have said it is 3. So of solution 1, pH is 3, that means H plus ion concentration is 10 raised to minus 3. H plus ion concentration of solution 2 is how much? They have said pH 4. So it is 10 raised to minus 4. H plus ion concentration of solution 3 is how much? They have said pH. It is 5. So it is 10 raised to minus 5. Understood? Total concentration of H plus ion solutions is equal to what? 10 raised to minus 3. First one. I'll take 10 raised to minus 3 outside. 1 into 10 raised to minus 1 plus 1 into 10 raised to minus 2. Yes. So we'll solve it out. 10 raised to minus 3. 1 by 1 plus 1 by 10 plus 1 by 100. Is that right? That comes out to what? Solve it out. You will get 1.11 into 10 raised to minus 3. So H plus ion concentration in mixture of equal volumes of 3 acids solution. Equal volumes I have said. So it will be equal to 1.11 into 10 raised to minus 3 divided by 3, because 3 solutions. That comes out to 3.7 into 10 raised to minus 4 molarity. Understood? So here first we get H plus ion concentration total. In equal volumes of 3 acid solutions they have said. So it is divided by 3. So answer is 3.7 into 10 raised to minus 4 molarity. Here it will not end. 3.7 it is. Yes. Next question. A weak acid HA has Ka of 1.0 into 10 raised to minus 5. If 0.1 mole of this acid is dissolved in 1 liter of water, the percentage of acid dissociated at equilibrium is closest to. Okay. A weak acid HA they have said. For a weak acid, so let us take, for a weak acid, how do you write degree of dissociation? Degree of dissociation is equal to what? How do we write it? Alpha is equal to root of, it is weak acid, Ka by C. Correct? So how much is Ka given? It is 1.0 into 10 raised to minus 5. So 1 into 10 raised to minus 5 divided by, how much is the concentration given? 0.1. Solve it out, you will get the answer 10 raised to minus 2. That is equal to 1.00%. 10 raised to minus 2 means 1.00%. Yes, 1 by 100. So correct option is what? Option A. That is the correct option. Understood? Clear with this? Okay. Next, calculate the pOH of the solution at 25 degrees Celsius that contains 1 into 10 raised to minus 10 molar of hydronium ions, that is H3O plus. Okay, how do you calculate? Let us take here H3O plus ions. How much they have given? H3O plus ions is 1 into 10 raised to minus 10. H3O plus is nothing but H plus ion concentration. Therefore, what will be pH? pH will be equal to 10, because 10 raised to minus 10. pH will be equal to 10. At 25 degrees Celsius, we know that pH plus pOH is equal to pKw and that is equal to what? That is equal to 14. Therefore, find the pOH. 14 minus 10, that comes out to 4. So what is the pOH of the solution? It is 4. So which is the correct option in our question? The correct option is option A. It is 4. Next question. The hydrogen ion concentration of a 10 raised to minus 8 molar HCl aqueous solution at 298 Kelvin, ionic product of water is 10 raised to minus 14. Even if they don't give us ionic product of water, we can calculate. They have said 10 raised to minus 8 molar HCl. So 10 raised to minus 8 molar HCl is nothing but 10 raised to minus 8 molar H plus ion concentration, because it is a strong acid. And also from water, we know that water being a neutral solution, the H plus ion concentration is equal to 10 raised to minus 7. So total H plus ion concentrations will be equal to what? 10 raised to minus 7 plus, I have to make it 10 raised to minus 7, 0.1 into 10 raised to minus 7. Is that right? So solve it out, you will get 1 into 10 raised to minus 7 plus 1 into 0.1. This comes out to 1.1 into 10 raised to minus 7 molarity. It is 1.1 into 10 raised to minus 7 molarity. So the correct option is 1 into 10 raised to minus 7 molarity. Yes. So which is the correct option? 1.0525 into 10 raised to minus 7 molarity. It comes around, I have taken it rounded off to 1.1. Is that right? Next question. At 25 degrees Celsius, the dissociation constant of a base BOH is 1.0 into 10 raised to minus 12. The concentration of hydroxyl ions in 0.01 molar aqueous solution of the base would be. Okay. So they have given us base here. We have to find. So see, concentration is given how much? The concentration given is 0.01 molarity. Right? And have they given us dissociation constant? Yes. Dissociation constant of the base given is 1.0 into 10 raised to minus 12. Correct? BOH being a base, yes, it dissociates to give what? To give B plus plus OH minus. Correct? If you look initially, the concentration is how much? C. And here the concentrations will be 0. At equilibrium, C concentration of this gets converted into dissociates. Therefore, C alpha is formed here and equally C alpha is formed. So how much remains? C minus C alpha. That I can write it as C into 1 minus alpha also. Is that right? Yes. Therefore, OH minus concentration is what? It is C alpha. Find it. OH minus ion concentration is equal to root of Kb into C. That is equal to what? Root of 1.0 into 10 raised to minus 12 into what is C? 0.01. Is that right? That is nothing but 10 raised to minus 2. So OH minus ion concentration comes out to what? 10 raised to minus 2, 10 raised to minus 12 becomes root of 10 raised to minus 14. Therefore, OH minus ion concentration is equal to 10 raised to minus 7 molarity. Or you can write 10 raised to minus 7 moles per liter. Yes. So which is the correct option? 10 raised to minus 1 into 10 raised to minus 7 moles per liter. So we have discussed few more set of questions here. In the next class, we will go to next set of questions. Yes. Hope you have understood all the concepts. Please practice them so that it will help us to solve the next set of questions in the next class. For now, thank you.